Hi students, welcome to our science class. Our chapter name is Essentials for Life, Air and Water. In the last few class we are discussing on this chapter and first session we discussed about air. In the last class we discussed about water. We just started that. And today we are continuing that topic and what we said. Water is the second essential thing for our life, and then we said that within our earth, 3/4 of all the region is covered with water. Only 3% of the total water is only we can drink, and other water is all ocean water and all. And there we said that normally water is not at all fit to drink when we get it from some sort of places. That means even if the water that we get from the tap itself has some sort of things are mixed, and we can call it as impurities. Impurities. So, what is the definition for these impurities? The definition is this: the substances that make the water unfit for use are called impurities. That means we need pure water, but when it is mixed with some sort of substances, then it is not fit to use. It's not fit to use means it's some sort of useless. So for that we can call that substance which is getting mixed on the water is called impurities. So the definition is this: the substances, there are some substances that make the water unfit for use are called impurities. So the thing is this: the substances that make the water unfit to use. That means it's not help for the purpose. Our basic purpose is drinking, bathing, like all the things. So this is the definition for impurities. You just want to remember this definition. Now we are going to study the types of impurities. Do these impurities are of simple type? No, there are different types of impurities are there. And now we are going to study one type of classification for these impurities. And the first type is soluble impurities and insoluble impurities. So, impurities are the substances that get dissolved in water that makes the water unfit to use. And here we can say two types of impurities are there. We are only studying these two types. And one is soluble impurities and the second one is insoluble impurities. Now the question is this: what is the soluble impurities and what is this insoluble impurities? Now we are going to discuss that. First we can study about the soluble impurities. Soluble impurities are all impurities that can dissolve in water are called soluble impurities. So the thing is this: soluble impurities are the impurities that can dissolve in water are called soluble impurities. What is this dissolve means? For example, I am not talking about the soluble impurities. I am just giving this example to identify what is this solubility or this dissolving. We are just taking one beaker, filling it with water and put 1 spoon of sugar or salt. I am just taking salt, mixing this salt and water. When I am stirring it continuously, what happens? That salt is completely disappeared from the water, and I can say it as the salt is getting dissolved in water. They are just getting disappeared means they are spread inside the water. They are getting dissolved. So this is only the example for dissolving. So here what is that? Soluble impurities means the impurities that can dissolve in water are called what? Soluble impurities. And the examples are these: salts of potassium and magnesium. Salts of potassium and magnesium are the examples for soluble impurities. So very simple. That is the definition for soluble impurities and the examples. Salts of potassium and magnesium. Now we are going to discuss about the insoluble impurities. Here for the soluble we said that it is completely dissolved in water, and actually this insoluble impurity means reverse of that. It won't dissolve in water. So as the definition we can say this insoluble impurities are all impurities that do not dissolve in water are called insoluble impurities. So the thing is, this all impurities that do not dissolve in water are called what? Insoluble impurities. Don't get confused with the soluble and insoluble. Soluble means that is getting dissolved in water. Insoluble means do not dissolve in water. And what's the example for these insoluble impurities? You may know that. The examples are these: sand and mud. Sand and mud are the examples for the insoluble impurities. So I think it's clear for you. Now we are going to do one activity, very simple activity. For that we just need one beaker and taking some water inside this. I am just taking some water in a beaker and I am taking some sort of substances like salt, sugar, sand, tea leaves, milk. So these are the other substances need for this activity. So my aim is to, I will just take one of the sample and mix it with this water. And I will check do it will dissolve in water or not. Then I will strain this using a strainer. What is this strainer means? That means the filtration. So I just take that mixture and transfer it through a strainer and will check do the substance is getting deposited on the strainer or not. That is my experiment. So first I am taking our salt. I am just taking a spoon of salt. So I am mixing this water plus salt. Now this is salt solution, mixture of salt and water. Now I am just taking one strainer and transferring this water, the mixture of water and salt through this strainer and observing do the salt is the left on this strainer. That is my activity. So what you can observe, do the salt is the left on this strainer? No, that salt is getting dissolved in the water and I can say this salt is it soluble or insoluble? Of course it is soluble substance. Soluble substance, this salt. Now we are repeating this activity using the water. Now our water is normal water, not mixture of salt and water. And I am taking the sugar. Now I am just taking the sugar, mixing it with water. Now this is sugar plus water. Here you can see when we are mixing the sugar in water, therefore sugar solution is formed. Now again I am repeating the same thing. I just want to pour this water on this strainer and just want to check, do the sugar is left on this strainer or this sugar solution is going to collect on this glass. That is my activity. I am just taking this beaker and pour this water on this strainer, and what you can see? You can see nothing is the left on this strainer. All this water is getting collected on this glass. So, do this sugar is dissolving? Yes, this sugar is dissolving in water. And now it is soluble or insoluble? Of course, it is soluble. Soluble in water. Now, we completed these two. The third thing is sand. I am just taking a spoon of sand and repeating this activity. So, I am just taking a spoon of sand and mixing it inside the water. Now, our water is within a small muddy color, some sort of slight color. Now, I am going to pour this water through this strainer. And what will happen? What you can see? Do the whole water will be moved to this glass with the mixture of sand and water? Now this water is mixture of sand and water. My question is this, do this water after transferring through this strainer still have the sand and water? No. That sand will left on this strainer and the water will only be there. So, now my question is this, do this sand is getting dissolved in water? No, the sand is not at all dissolving in water. So, is it soluble or insoluble? Of course, it is insoluble. We can say sand is insoluble in water. That means it is not getting dissolved. And the thing is this, we can separate the sand from water by simply using a strainer. So that's the sand. Now we are just taking the tea leaves. Same procedure. We are just taking a spoon of tea leaves and mixing it with this water. And now this mixture is what? Tea leaves plus water. And the same procedure, we are just transferring this water through this strainer. And what is this water? Do this the mixture of this tea leaves and water? No, you will get the water here. The tea leaves are the left on the strainer. So, do these tea leaves are getting dissolved in water? No, the tea leaves are do not getting dissolved in water, and so is it soluble or insoluble? Insoluble. That is insoluble. Insoluble. Now the last thing, that is our milk. I am just taking a spoon of milk and adding this to our beaker of water. When I am just adding a spoon of milk, what you can see a particular whitish color in our water. And here also I am just stirring it well. And what I am doing, I am going to do this water to pour on this strainer. What happens? Do you will get the milk on this strainer and this clean water you can get here? No. The thing is this, milk is it dissolved or not? Milk will get dissolved in this water, and so when we are just straining this, what happens? All together the mixture of milk and water The same thing you will get here also. That means this milk and water is getting dissolved. Milk is getting dissolved in water, and is it soluble or insoluble, this milk? Obviously it is soluble. It is soluble in water. So that's the thing. So within this activity, we are just mentioning that some of the things are soluble in water and some of the things are insoluble in water. Here, the salt, sugar, milk all are soluble in water, and the substances like sand, tea leaves all are insoluble in water. This is a simple activity that you mentioned in your textbook, and that's why we are explaining this. Next topic is removal of impurities from water. Removal of impurities from water. Already said that some of the impurities are there mixed in water. And now we just want to remove these impurities from water to make it useful. So there are different methods to make this pure. That means we can separate these impurities in different methods, and now we are going to discuss that. First we are going to discuss about the insoluble impurities. That means how we can separate these insoluble impurities from the water. That is our topic. That means insoluble means the substances which are not dissolving in water. So that is the first topic. The first method is this. The name you just want to remember, sedimentation. Sedimentation. What is this sedimentation? That we want to study. We already said that this insoluble impurities example is sand. So I am just taking a beaker, filling it with water, adding some sand, mixing it continuously. So now this water is the mixture of water and sand. Now the thing I am going to do, just observe, keep it undisturbed for some time. That means I am not shaking this, I am not stirring this, I am just keeping it undisturbed for some time. After some time, what you can see, do still the sand and water will get spread like this? No, you can see that the sand particles are getting deposited under this water. The pure water is at the top. So actually the settling of high weight particles by undisturbing is called what? Sedimentation. That process is called sedimentation. The example is this: when we are just mixing the sand with water and we are just keeping that mixture undisturbed for some time, for 5 minutes, 10 minutes or 15 minutes, then you can see that the sand particles get deposited, or muddy water. This mud gets deposited under the water, and the pure water you can see at the top. So that is what? Sedimentation. And so we can say here the mixture is kept undisturbed. This undisturbed term is important. Here we are keeping the mixture undisturbed for some time. We are just keeping it undisturbed for some time. And the heavy objects, the thing you just want to remember, this sand is heavy. Sand is getting heavy, or sand is having heavy weight than the water. So the heavy particles are getting settled down. The heavy particles are getting settled down, and the water is there at the top. So this process is what? This process is called sedimentation. So we can say here, this is the definition. Here the mixture is kept undisturbed for some time and the heavy particles are getting settled down and the pure water is left on the top. This process is called sedimentation. And the thing is this, I can call this sand a name. That means what is getting deposited at the bottom is having a name and that is sediment. That is, what is happens the sedimentation? Sedimentation means settling down. So who is getting sedimentation? That is called what? Sediment. Here for this experiment, sand is sediment. When we are just taking muddy water, the mud is the sediment. These are the examples. So we can say, suppose we are just taking a beaker, mixing it with tea leaves. After some time you can see that the tea leaves are get deposited down after some time. In that case, I can call sediment is the tea leaves. What is getting deposited down? That is sediment. And the process of this settling down is called what? Sedimentation without the disturbance. That means when we are keeping it undisturbed for some time, what happens? The heavy particles are getting deposited and I can call this process is called sedimentation and the settling particles are called sediment. I think it's clear for you. This is the first method, sedimentation. The second one is this decondition. Decondition. So, here in the last experiment, we just observed that we are just taking a beaker which is mixed with sand and water, sand. They are just mixing together and we are just leaving it for some time and this sand is getting deposited or settled down at the bottom. This decondition is something related to this. That means I am just taking another beaker and pour this water to this beaker without disturbing this deposited sand. That means I am not mixing this sand, not like that. This sand is just deposited at the bottom and here I am just taking this beaker, slowly pour this water on this beaker without disturbing this sand. The meaning is this, our water will be transferred to this, but our sand is still remain in this beaker. So, this pouring of water, this clean water to another beaker is called what? Decondition. So, we can say this is also a type of removal of impurities. That means, here we are just taking out or taking away the pure water to another beaker without disturbing the impurities and that is called what? Decondition. So, this is actually a continuous process for the sedimentation. We can say after sedimentation, the clear water can be poured gently into a separate beaker without disturbing the sediment. So, after sedimentation, we are doing this decondition always after the sedimentation. After sedimentation, the clean water can be poured gently into a separate beaker without disturbing sediment. Who is the sediment? Our sand is the sediment. So, after sedimentation, the clean water can be poured gently to a separate beaker without disturbing our sediment. So, this is what? Decondition. This is also a type of what? Removal of impurities. The next is about the filtration. That is also something we can discuss. This is also the separation of impurities that is insoluble. This filtration is not possible for the soluble substances, and not only that, this sedimentation, decantation, these all are not possible with the soluble substances. This is only possible for the insoluble substances. So this filtration and also the separation of the substances for these soluble substances and also some sort of separation of the waters, impurities, everything we can discuss in the next class. I think it's enough for today. We will meet in the next class with these topics, and that day we can conclude this chapter. You just want to read all these things in your textbook and also want to need to complete the notebook. We will meet in the next class with further topics. Thank you.